What's up guys, this is Massey. Welcome to another video. In this video I want to talk about matrix and matrices and do some examples. Matrix is a rectangular array of numbers and it's basically a tool in linear algebra for solving system of linear equations. As you see here, matrix is an ordered rectangular array of real or complex numbers, and we have basically horizontal lines and vertical lines. The horizontal lines are called rows and the vertical lines are called column. So in this example, the matrix A we have, and it says what is the dimension of matrix A. When we are talking about dimension, it is basically shown by m times n, when m represents the number of rows and n represents number of columns. So in this example, there are 3 rows and 4 columns. So the dimension of this matrix is 3 by 4. 3 number of rows, 4 number of columns. And it says number of rows is going to be 3 and number of columns is going to be 4. Next question, it says what are the rows and columns? I'm going to say first row is -2, 5, 4, 4. Second row will be 1, 2, 3, -2. Third row will be 3, -2, 1, -3. On the other hand, columns, first column is -2, 1, 3. Second column is 5, 2, -2. Third column is 4, 3, 1. And finally, fourth column is basically 4, -2, and -3. So that's the answer for the first example. Now I want to show you in what condition two matrices are equal, or equality of matrices. Two matrices are said to be equal if they are of the same order. That's very important, same order. And for I and j, it means that the order of the elements, ijth entries or ijth element of the two matrices are the same. It says a 2 by 3 matrix can never be equal to a 3 by 2 matrix since their orders are different. For example, this on the left hand side, the order of this matrix is 3 by 2, and on the right hand side is 2 by 3. So since the order is not the same, so these two matrices are not equal. Next example, again it is 3 by 2 and 2 by 3, although all the elements looks like the same, but since the order of the matrices are different, so these two matrices are not equal. And what about next one? Here we have 2, 3, 1, 5, 1, -2, 2, 3, 1, 5, 1, -2. As you see here, the order of both matrices are 3 by 2, 3 rows and 2 columns, and each of these elements are the same. So in this case, we're going to say that these two matrices are equal. Next concept is square matrix. Whenever the number of rows and number of columns in a matrix are the same, it means that we are dealing with a square matrix. like matrix 1 by 1, 2 by 2, 3 by 3, 4 by 4, and so on. And m by n matrix is said to be a square matrix if m equals to n. That is, the number of rows equals to the number of columns. For example, here this matrix, it is 1 by 1. We have one column and one row. This matrix, we have 2 rows and 2 columns. It is a square matrix. Here we have 3 rows and 3 columns, a square matrix as well. And here we have 4 by 4, which means that we have 4 rows and 4 columns. So this one is a matrix, square matrix as well. So that's 1 by 1 square matrix, 2 by 2 square matrix, 3 by 3 square matrix, and 4 by 4 square matrix. So if the number of rows and number of columns are not the same, we cannot say they are square matrix. So now I want to talk about vertical matrix and horizontal matrix. For an m by n matrix, matrix A is called a vertical matrix if m is greater than n. It means the number of rows are more than the number of columns. And a horizontal matrix if m is less than n, which means that number of columns are more than number of rows. For example, here we have 2 rows and 3 columns, so we are dealing with horizontal matrix. Here we have 3 rows and 2 columns, so number of rows are more than number of columns, so we are dealing with an vertical matrix. So we can say that any matrix must be either a square matrix or a vertical matrix or a horizontal matrix. Next topic is row matrix and column matrix. A matrix is called a row matrix if it has only one row. For example, as you see here, we have one row and it doesn't matter how many columns we have. So since we have one row, we call it a row matrix. On the other hand, we have a column matrix. A matrix is called a column matrix if it has only one column. So as you see here, we have one column in this matrix. Doesn't matter how many rows we have. So since we have one column, it's called column matrix. Another term is zero matrix. A matrix is called a zero matrix or null matrix if all its elements are 0. And zero matrix is usually denoted by O. So some examples of zero matrix are here. Basically can be 1 by 1, 2 by 2, 3 by 2, and 3 by 3. As you see here, all elements of zero matrix are 0. Next topic is diagonal of a matrix. If A is a square matrix of order n, it means that n by n, number of rows are n, number of columns are n as well. Then the elements A11, A22, A33, and so on all the way to n, A, and n are called the diagonal elements. And the line along which these elements lie is called the principal diagonal or main diagonal or simply the diagonal of the matrix. For example, as you said, it has to be square matrix. Here we have matrix 2 by 2 and the diagonal elements are 2 and negative 3 as you see here. In this example, we have a matrix 3 by 3 and the diagonal are 2, 3 and negative 5. 2, 3 and negative 5 are the diagonal elements. Now, what is a diagonal matrix? A square matrix A is said to be a diagonal matrix if elements are 0 when I and j are not equal, and those on the diagonal is 0 or non-zero. It means that if aij equals to 0 for all I not equal to j, except those in the diagonal of A, all the entries in A are zeros. For example, and the one diagonal elements need not be 0. For example, in here, this is the diagonal of a matrix. However, the other two elements are 0. Doesn't matter what numbers we have here. Same thing in here. The 3 by 3 is a square matrix. The diagonal of a matrix is 2, -1, and -3, and all other elements are 0. So that's why we call it a diagonal matrix. And here we have 4 by 4 matrix. The diagonal elements are 3, -1, 1/2, and -1, but the rest of the elements are 0. So these are different examples of diagonal matrix. So for diagonal matrix, all elements which are not diagonal of a matrix are supposed to be 0. Now, what is a scalar matrix? Scalar matrix is a diagonal matrix if all diagonal elements are equal and the other elements are zeros. So it means that we have a diagonal matrix and all diagonal elements are equal. So for example, here A, all the way, diagonal line, and the rest is 0. For example, here we have 2, 0, 0, 2. That's a scalar matrix. If we have -3, 0, 0, 0, -3, 0, 0, 0, -3, that's another example for a scalar matrix, because we have a diagonal matrix since all other elements are 0 and the diagonal elements are equal. Special case of scalar matrix is called identity matrix. A scalar matrix is called an identity matrix or a unit matrix if each of the diagonal element is the number 1. So it means that all diagonal elements are 1 and all other elements are 0. As you see here, we have I1 when it is 1 by 1. I2, the diagonal elements are 1. I3 is 3 by 3 matrix and all diagonal elements are 1. The next concept I want to talk about is about triangular matrices. We have upper triangular matrices and we have lower triangular matrices. If Aij equals to 0 for all elements that have I greater than j, we are dealing with upper triangular matrices. However, if Aij equals to 0 for all elements that j is greater than I, we are dealing with lower triangular matrices. Let's see some examples to digest it better. So in this example, as you see here, diagonal elements and all other elements on top of that are non-zero. However, all elements under the diagonal elements are 0. So that's why we call it upper triangular matrices. Again, all elements below the diagonal of a matrix is 0. And here we have 4 by 4 matrix and all elements below the diagonal of a matrix is 0. It doesn't matter here if it's 0 or non-zero, but the elements under the diagonal of a matrix must be 0, all of them. So that's why they're called upper triangular matrices. On the other hand, we have lower triangular matrices, which all elements above the diagonal of a matrix are zero. And here we have these 3 0, and we have all these things 0. So all of them are above the diagonal of a matrix. As I said, doesn't matter if the rest are 0 or non-zero. As you see here, we have 0 here, and we have 0, doesn't matter. But however, all the elements above the diagonal of a matrix must be 0 in order to have the lower triangular matrix. Now let's talk about addition of matrices. If we have two matrices, A and B, they need to have the same order, m by n. Then we can add these two matrices if we add each of its corresponding elements. For example, here we have two matrices. This one is 2 by 3 and this one must be 2 by 3 as well in order to be able to add these two. So I'm gonna say A plus B will be here 2 plus 1, negative 1, 0 plus 2, 1 plus 3, negative 3 plus 0, negative 1 minus 2, 5 minus 3. Which means that A plus B is going to be the same order matrix, which is 2 minus 1 is 1, 0 plus 2, 2, 1 plus 3, 4, negative 3 plus 0, negative 3, negative 1 and negative 2, negative 3, 5 minus 3 is 2. So it is also 2 by 3 as well. So that's how we add the matrix. So the most important thing is the size of or the dimension of the matrices must be exactly the same. Now I want to show you a multiplication of a scalar by a matrix. If matrix is 3 by 3, 2, negative 1, 3, negative 2, 0, 1, 7, negative 3 and 4, and then we want to find out 4a. It means that 4 times a. It means that we need to multiply all the elements by 4. So 4 times 2, 8. 4 times negative 1, negative 4. 4 times 3, 12. 4 times negative 2, negative 8. 4 times 0, 0. 4 times 1, 4. 4 times 7, 28. 4 times negative 3, negative 12. 4 times 4, 16. So that's gonna be the answer. So that's how we multiply scalar by a matrix. So the answer has to be have the same dimension or same size as the original matrix. Now in this example, it says let A and B be 2 by 2 matrices. Find matrix A and also matrix B such that 3A plus 2B equals to 9, 4, negative 2, negative 6. And 2A plus 5B is 17, negative 1, 6, and negative 15. So if I assume A is A11, A12, A21, and A22, and also if I assume B is B11, B12, B21, B22, and we are 100% sure that these are supposed to be 2 by 2 matrix because we are adding them and we get the 2 by 2. So based on that, I'm gonna say 3 times A11, A12, A21, A22 plus 2 times B11, B12, B21, B22 equals to 9, 4, negative 2, negative 6. So I'm gonna say 3A11 plus 2B11, 3A12 plus 2B12, 3A21 plus 2B21, 3A22 plus 2B22 equals to 9, 4, negative 2, negative 6. So that's gonna be 3A11 plus 2B11 equals to 9. 3A12 plus 2B12 equals to 4. 3A21 plus 2B21 equals to negative 2. And 3A22 plus 2B22 equals to negative 6. So this for equation. And based on 2A plus 5B equals to this matrix, I can say then we write the final one here, so don't waste time. 2A plus 5B equals to this. So it's gonna say 2A11 plus 5B11 equals to 17. 2A12 plus 5B12 equals to negative 1. 2A21 plus 5B21 equals to 6. And finally, 2a22 plus 5b22 equals to negative 15. Now, pair of equations, pair of equations, pair of equation, pair of equation. So we need to use eliminations or substitution method. It's better to use elimination method in order to find out each of these values. For example, 3a11 plus 2b11 equals to 9. 2a11 plus 5b11 equals to 17. So I multiply this one by negative 3 and this one by positive 2, and then you add it. Then you find these numbers. A1, 2 to be 2. A1, 2, negative 1. A2, 2, negative 2. B2, 1, 2. A2, 2, 0. B2, 2, negative 3. And A11 equals to 1 and B11 equals to 3. So A will be 1, 2, negative 2, 0. B will be 3, negative 1, 2, negative 3. So these are going to be the answer. This example, it says evaluate the following: cosine theta times cosine theta sine theta negative sine theta cosine theta plus sine theta times sine theta negative cosine theta and sine theta. So that's basically, first of all, let's multiply this. Cosine theta times cosine theta, cosine square theta. Cosine theta times sine theta, sine theta, cosine theta. Cosine theta times negative sine theta, negative sine, cosine, and cosine times cosine, cosine square theta. Plus sine theta times sine theta is going to be sine square theta. Sine theta times negative cosine is going to be negative sine theta cosine theta. Sine times cos, sine theta cosine theta. And sine times sine, sine square theta. When you add them, you're going to have cosine squared theta plus sine squared theta. Sine theta cosine theta plus negative sine theta cosine theta, 0. Negative sine theta cosine theta plus sine theta cosine theta is going to be 0. And then you have cosine squared theta plus sine squared theta. That's going to be equal to 1, 0, 0, 1. That's identity matrix. Next example. It says compute the matrix X if it is given that 2x plus 3a equals to 3b. So 2x plus 3a equals to 3b. A is given, b is given. So 2x is going to be 3b minus 3a. So 2x is 3 times a, 1, negative 1, 0, and 2, minus 3 times 3, 5, 4, 6. That's going to be 3 times 1, 3, minus 3 times 3, 9. So 3 minus 9 is going to be negative 6. 3 times negative 1, negative 3. Here we have negative 15, so negative 18. 3 times 0, 0. Negative 3 times 4, negative 12. 3 times 2, 6. Minus 3 times 6, 18. Negative 18 and 6, negative 12. So that's going to be the value of x, 2x basically. X will be each element divided by 2. So which will be negative 3, negative 9, negative 6, and negative 6. Let's see what's next. Next is multiplication of matrices. So what is the multiplication of matrices? Let A be an m by n matrix and B an n by p matrix. If A is element is Aij and B is Bij, then product AB is defined as the M by P matrix, and Cij, where Cij is sigma R1 to N AIR times BRJ, which will be the expansion here. Let's see an example. It's going to be much easier if you see an example. First of all, when we multiply two matrices, A in this case, it is 2 by 2, and here B is 2 by 1. So the number of the columns of the first matrix has to be equal to the number of rows of the second matrix. So when we multiply A and B, the number of columns in the first matrix has to be equal to the number of rows on the second matrix. Otherwise, we cannot multiply these two. So A times B will be, and what is going to be the size of the product? These two cancel out and we have 2 and 1. That's going to be the size of the product, which we have 2 rows and 1 column. 2 times -1, -2. 3 times -3, -9. -1 times -1 plus 1. 0 times -3, 0. So it is going to be -11 and 1. So that's the answer. Next one. Let A be a 4 by 3 matrix and B be a 3 by 2 matrix given by here 4 by 3, and here we have 3 by 2. So the number of columns of the first matrix equal to the number of rows of the second matrix. It means that the product is going to be 4 by 2. 4 number of rows, 2 number of columns. So let's multiply. So 4 rows and 2 columns. So we're going to have, that's going to be 4 by 2. So we have A, let's call it C, C11, C12, just keep writing A, C21, C22, C31, C32, C41, C42. So C11 is 2 times 2 plus 3 times -2 times plus -1 times 1. So one more time, 2 times 2 plus 3 times -2 plus -1 times 1. So that's going to be 4 minus 6 minus 1. That's going to be -3. Next one, C12. That's going to be 2 times -1 plus 3 times 0 plus -1 times -1. 2 times 2. Actually, 2 times -1 plus 3 times 0 plus -1 times -1. -2 plus 1, -1. Second row, 1, 0, 3, and here we have 2, -2, 1. So 1 times 2 plus 0 times -2 plus 3 times 1. That's going to be 2 plus 3, 5. Next one is C22. 1 times -1, 0 times 0, 3 times -1. So it's going to be -1 minus 3. It's going to be -4. Next one, C31. C31 is 0 times 2 plus 1 times -2 plus -2 times 1. going to be negative 2, negative 2, negative 4. C3, 2. 0 times negative 1, 0. 1 times 0, 0. Negative 2 times negative 1 is going to be positive 2. C4, 1 now. Negative 2 times 2 plus 3 times negative 2 plus 1 times 1. One more time. Negative 2 times 2 plus 3 times negative 2 plus 1 times 1. Which is going to be negative 4, negative 6 plus 1. It's going to be negative 9. C4, 2 is going to be negative 1 times negative 1 plus, negative 2 times negative 1, 3 times 0, 1 times negative 1. It's going to be 2 plus 2 minus 1, which is going to be. So the answer is going to be, I'm going to write it here, negative 3, negative 1, 5, negative 4, negative 4 again, positive 2, negative 9 plus 1. That's going to be the final answer. Now in this example, let's A be 1, 0, 2, negative 1, and B is 2, 1, negative 1, and 0. Show that A times B and B times A may not be equal matrices. So this is 2 by 2, here is 2 by 2. So let's calculate. 1 times 2 plus 0 times negative 1. 1 times 1 plus 0 times 0. 2 times 2, negative 1 times negative 1. 2 times 1 plus 0. So that's going to be 2, 1, 5, 2. That's going to be A times B. B times A is 2 times 1 plus 1 times 2. 2 times 0 plus 1 times negative 1. Negative 1 times 1 plus 0 times 2. And finally negative 1 times 0 plus 0 times negative 1. So that's going to be 2 plus 2, 4. Negative 1, negative 1, and 0. And that's BA. So A dot B is not necessarily equal to B times A. Next example. Let A and B be non-zero matrices given by A 2, 2, 2, 2, B 2, negative 2, negative 2, 2. Show that A times B and B times A are zero matrices. So A times B is going to be 2 times 2, 2 times 2 plus 2 times negative 2, 2 times negative 2 plus 2 times 2, 2 times 2 plus 2 times negative 2, 2 times negative 2 plus 2 times 2, which will be 4 minus 4, negative 4 plus 4, 4 minus 4, and negative 4 plus 4, which makes it 0, 0, 0, 0. So the multiplication of two non-zero matrices give us a zero matrix. Next example. For a non-zero matrix A and a positive integer A, a to the power n may be 0, but A might not be 0. For example, A is 2, 4, negative 1, and negative 2. Find A squared. So it's going to be 2, 4, negative 1, negative 2, multiplied by 2, 4, negative 1, negative 2. That's going to be 2 times 2, 4, plus or minus 4 times negative 1. 2 times 4, 8, minus 8. Negative 1 times 2, negative 2. Negative 2 times negative 1, negative 1 times 4, negative 4. Negative 2 times negative 2 is going to be positive 4. So that will be 0, 0, 0, 0. So although A is not a non-zero matrix, it's a non-zero matrix, a to the power of 2 is a zero matrix. So these are some examples for introduction to matrix calculation. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.